Okay, let's do some problems like number 6. Okay, let's take a look at this. And some of you are making this harder than it needs to be. So this is full. Oh, go to y equals clear. It's 4 divided by, this is a different problem, x plus 1, close parenthesis, squared. Graph. And so this is, we're trying to find the area between this curve. I'm going to go zoom 4. The area underneath this curve from 1 to infinity. Well, the area is getting smaller and smaller, so it may go to 0. It may not. We shall find out. The problem with doing this is called an improper because it goes to infinity. Definite integral that goes to infinity is called an improper one. There are some other types of improper. So when you have the improper and infinity, or I'm going to show you something else, you always write the limit as a or b or c or some variable, let's call it a, approaches infinity, and replace the infinity with an a, and that's 4 over x plus 1 squared dx. Now what we want to do is we want to work this out. Now some of you are not very good at keeping this limit thing in here, so I'll show you how you can handle that. I'm going to write it, and the next thing I'm going to put here is what this works out to be. I'm going to come down here and go 1 to a of 4 over x plus 1 squared dx. I need to evaluate that integral. And you should know how to do that from chapter 5. When you got something like this, we can let u be that mess. We can let u be the x plus 1. du would equal dx. And so this would become no longer 1 and a. You could put in 1 in here and it would be 2. And a in here would be a plus 1 if you want. Or we can change it back, or I'll put it in here, but I'll show you that I can change it back. It would be 4 over the x plus 1 is my u, and it's squared, and dx is the same as du, so I can do this integration. Now, some of you are still thinking that anytime you got something in the denominator, it's ln. It's only ln if it's just a single variable, x or u. If it's square root or got a power besides 1, you cannot just, it's not ln. Now this one turns out to be 4 times u to the minus 2. The 4 can be pulled out. And u to the minus 2, you would add 1, which makes it u to the minus 1, and you'd have to divide by minus 1, so you get 4 u to the minus 1 divided by minus 1, evaluated from 2 to a plus 1. We put the a plus, let's see here. Let's clean that up. So minus 1 can be taken up here, so it could be minus 4, and u to the minus 1 is 1 over u. And you want to get that with a positive exponent so you can follow this. Evaluated from 2 to a plus 1. Now we put the a plus 1 in for u and the 2, then the 2 in for u and do the subtraction. Or we can change u back to x plus 1 and then put in our original limits, 1 to a. Either way, we will get negative 4 over a plus 1 minus a minus 4 over 2. Okay, so I've worked this integral out. I put that back in place of the integral in here. Minus 4 over a plus 1 minus a minus, which is plus 4 over 2, or 2. And now I got to look at this. What happens as a goes to infinity? Well, this denominator would get really big, but when a denominator of a fraction gets really big, the fraction gets really small and approaches 0. And so this goes to 0, and this stays 2, 4 over 2, or 2. And so this one would converge to a value of 2. The area under this curve that I had here, from 1 to infinity adds up to be 2. Okay? All right, let's do another one. Let's see here. I'll do one like I had on the test. The integral from, let's say 5 to 7 of 1 over x minus 5 times ln of x minus 5 dx. Now what does that look like? So I have 1 divided by parenthesis, x minus 5, close parenthesis, ln, parenthesis, oh, it already does a parenthesis, x minus 5, close parenthesis, graph. All right. So we can't see it because it's over here, so zoom 6, maybe we can see it better there. And so I want to go from 5, which is 1, 2, 3, 4, 5. Did I type something wrong? X minus 5. Yeah, no, I got it right. From 5 to infinity. So it's got a lot of this crazy stuff going on here. But let's just do this one and see what happens. How do we get this one, figure out what this is? Oh, I know what. I want to go from 6 to infinity. There's what I want to do, because I didn't want to get this involved. 6 is right here. 6 to infinity, it might work. I don't want to get involved with this. 6 to infinity. All right, there's 6 to 7. 6 to 7. All right. Now I said use substitution. Well, if I let u be x minus 5, it's just going to be 1 over u times ln of u du. I want to get ln. Whenever there's an ln, we've got to work with it. Can't have ln in an integral. That causes us all kinds of issues. So I'm going to let my u, and what I was hoping u would do, be the ln of x minus 5. Now, if I take the derivative, I get du, and the derivative of ln of something is 1 over the something times the derivative of the inside, which is 1, dx. Some of you have forgotten your derivative rules. So this becomes, since I'm doing a u sub, this is no longer 6 and 7, but it'll be, oh, but the problem here, what is the problem here? Well, if we put in 6, that's 1, that's not a problem. ln of 1, though, is 0, and we'd have division by 0. So 6 is the issue. So I'm going to write limit as a approaches 6 of the integral from a, no longer 6, but a to 7. And inside I have 1 over x minus 5 times ln of x minus 5 in that denominator, dx. Now, if you don't like writing the limit all the time, we could say limit as a approaches 6, and we can jump down here and work out this integral as from a to 7 of 1 over x minus 5 ln of x minus 5 dx. Do my u substitution, and I'm going to have the ln of x will be u, and this will be still there, so I'll have integral changing, so that I'm not going to have those same limits. It's going to be different. It'd be ln of 7 minus 5, ln of 2, and ln of a minus 5. Those would be the new limits. ln of a minus 5 and ln of 2 if I wanted to figure them out. And then I'd have 1 over x minus 5 and u, now dx. So to solve for dx, since it's divided by this, I'd have to multiply by x minus 5 on both sides. And so dx would equal x minus 5 times du. So dx will be replaced with x minus 5 times du. Those cancel now, and I have it all in terms of u. I can't have any mixed stuff. So this becomes when I integrate 1 over u, I get ln of u, evaluated from ln of a minus 5 to ln of 2, and I can plug ln of 2 into here minus ln of this. Or I can switch it back to my x's. We'll get the same answer I think you'll see here in just a sec. My u was this, so I'd have ln of u, which was ln of x minus 5. And if I do that, I'd be back to my original limits, a to 7. If I put 7 in there, I get ln of 2, which is what I would have had if I put the ln 2 in there. ln of 2 minus, now I got to put a in there, so I'd get ln of a minus 5. And that would be what this inside works out to be. Now I have to take the limit of that. So I'm going to write ln of 2. Well, ln of 2 is a number, ln of a number is another number, so this is a number. That's perfectly okay. We have minus ln of a minus 5 Now, is this okay as a goes to 6? As a goes to 6, there's no a, so that's fine. But this, 6 minus 5 is 1. ln of 1 is 0. What's ln of 0? So let's look at the ln graph. And make sure my phone doesn't die on me. So I go ln, graph. Clear that one, and I'm going to do ln of x and look at it and see what happens as we go towards 0. It goes off to negative infinity. So this part goes to negative infinity. So this does not have a value. It has this value minus infinity, which goes all of this goes to positive infinity. So it's divergent. Okay, let's do one more. Let's do the integral from 0 to pi over 2 tangent x secant x dx. Let's see what that looks like. Tangent x secant is 1 over cosine. So divided by cosine x. By the way, somebody had their calculator in degrees, and that messed them up on problem number 1. Okay, graph. So now I'm trying to find the area between 0 and pi over 2. So pi over, let's go zoom trig. So now these are in, that's pi right there, and that's pi over 2. So we're looking for the area between here and there, and that goes up to infinity. So let's see what this looks like. So at pi over 2, it's going to infinity. So it looks like the problem is at pi over 2. So I would have to say limit as a approaches pi over 2 of the integral from 0 to a of tangent x secant x dx. Okay? And then if you don't like to keep doing the limit, we'll leave the limit up here as a approaches pi over 2, and we'll come down and do this one. The integral from 0 to a of tangent x secant x dx. Now, some of you look at the integration tables and you think this is the only parts that are integration to here. And these are derivatives. Yes, but derivatives backwards are integration. So if you had to integrate cosine, it becomes sine. If you have to integrate negative sine, it becomes cosine. If you have to integrate this, it becomes this. One of the problems on the test was something that looked like this, which integrates to arctangent. That's arctangent. Well, we have to integrate tangent secant. Well, tangent secant integrates to be secant. The derivative of secant is secant tangent. So this becomes secant x evaluated from 0 to a, which is secant a minus secant 0. Now, secant is 1 over cosine. So this is 1 over the cosine of a minus 1 over the cosine, what did I put theta here? 0. Cosine of 0. That 0. So here we have 1 over the cosine of A minus 1 over the cosine of 0 is 1. If you remember your unit circle, cosine is the x-coordinate. Here is 1. So this is 1 over 1, or just 1. So what happens here? Well, what's the cosine of pi over 2? Well, pi over 2 is here, and the cosine becomes 0. If the denominator of a fraction goes to 0, the whole fraction gets really large, and so this would diverge. Okay? Shall we do one more of these, or do you got it? Let's see. Well, I'll call it good for tonight.